Hi, welcome to Map Your Business Inside and Out. My name is Brendan Kinney. I work with developer relations with Geo, working the Maps API and the Earth API.
Hi, I'm Chris Broadfoot. I work on the developer relations team in Sydney, and I work on the Maps API. You can follow me on Twitter at Brody, and Brendan is Brendan Kenny. And if you'd like to tweet about this session, use these hashtags, so #IO2011 and #Geo. So, what are we going to talk about today? The title's Map Your Business Inside and Out. What does that really mean? Let's just have a quick flick through of what we're going to talk about. So first of all, mapping business locations. So essentially mapping all the locations of your business or store across the world, and you'll end up with something like this. Then we'll move on to seamless overlay of floor plans. So if you have imagery, this is the Moscone Center, this is the IO floor plan. If you have something similar for your own business, you can overlay that on Google Maps and seamlessly integrate with the Google base tiles. We'll then move on to annotating that map, so making it useful for your users to find things indoors. And then also having a quick look at searching over indoor features. So often your users won't know the exact location of what they're looking for, so this will help them find it. And then we'll have a look at navigating indoors using Street View. So first of all, mapping business locations. For the purpose of this talk, we're going to use a case study, and that's going to be Google. So basically, we're going to map all of Google's office locations around the world. So the first thing I did was I went to Google's corporate website, and luckily I found this JSON feed of all the offices, all of Google's offices. So basically, it's an array with details about each office, the office name, latitude and longitude, the precise location, a nice address for formatting, and a phone and fax number in some cases. So the first thing I wanted to do with this was import it into Fusion Tables. So Fusion Tables allows us to map many thousands of markers really quickly and easily. Obviously Google doesn't have that many locations, but it allows us to map it really, really simply. So importing into Fusion Tables is quite simple. It supports these data formats: CSV, Microsoft Excel, Open Documents Spreadsheet, and KML. So I chose CSV for this, and I used this super simple bash script, and the output of that was a nicely formatted CSV file. So I just hopped into Fusion Tables, went into the import dialog, imported my CSV file, and I ended up with a table like this. So this data format's kind of interesting, but what we want to do is put this on a map, right? Map each of these locations. So what I did was, I hit Visualize Map, and I end up with something like this. So Fusion Tables allows us to embed this really easily on my website with just this embed tag. So Fusion Tables will generate that tag for you, and I've actually used that exact code on this slide. They're HTML slides. So this is quite nice because I can go over and click on, I can click on a particular location, and I get some structured data about this. It's just actually going to zoom back normal because I think that's mucking with the. So I get some structured data, but this is not really useful for your users, right? And you might have some other existing map data. You might have other markers that represent other things. So what we can do is embed this Fusion table on a Google Maps API map. Now you can tell this is a Google Maps API map because I've styled it. So you may want to style your map, to suit the colors of your business. You may want to brand the map a little bit. You can turn off distracting features and labels also. So this gives the same functionality as the Fusion Tables iframe embed. As I click on a marker, I get a little info window with the content of that particular location. So this is really simple to do. It's just these two lines of code. I create a new Fusion Tables layer, pass it in the table ID, and set the map. But this is still not really useful for your users. I mean, it might be pretty, but we've still got this quite, frankly, ugly representation of that data in that info window. So what I've created is a library that makes this really easy to do. So this is the store locator library. And it basically helps you create applications like this. You can use any data source. For example, if you have an existing MySQL database, you can easily hook that into this library. But it's super simple to use with Fusion tables. I've created a hook-in for Fusion tables into this store locator. So it really reduces the lines of code to create great store locator. It also gives geolocation so that the user's presented with a useful viewport when they first visit the map. It has location search, including autocomplete. So yesterday we announced the autocomplete functionality, which you can attach to any text field. So if geolocation doesn't give a nice initial viewport, then they can search for their precise location. Has feature filtering, which I'm not actually going to show today, but if your store has particular features, then the user can easily filter using checkboxes. Also gives support for directions so that they can easily find your business, and a link into Street View. And this is not only for storefinder applications, it's for any application where you want to plot multiple locations on the map, such as Google Office locations. And it's going to be open sourced. Well, shortly after I/O, it will be available at this link. We're still waiting on some functionality from Fusion tables for the Fusion tables stuff to be really easy. So what does it look like? It looks much like the basic Fusion tables map, but you can see here immediately that the map is centered on San Francisco. So basically, the geolocation API in the browser has told the store locator that we're located in San Francisco. And as I click on a location, such as the Google San Francisco office, I get a nice formatted info window with the address and title, the name of the location. And for the purpose of this talk, we've added Moscone West as a location, just to make it a bit exciting. So, that's still not really compelling, right? I've created this store locator panel component. So, here I've put it on the left. It's just positioned using CSS. So you can put it anywhere you like. Maybe on a mobile device, you'd want to switch between the map and the panel. And so basically, it's just that one line of code. I give the panel the DOM element, so basically a div that I've placed on the left. And the panel gives us some really nice functionality. So, once again, we're centered on San Francisco, but perhaps we want to look at Mountain View. So I can go here, hit Mountain View, and the first location is the Mountain View campus. So I can click on the left, to find the closest location in the viewport. I can go and get directions straight away. So this is going to go from downtown Mountain View to the Mountain View campus. And I can, drag directions, and the panel on the left is updated. But let's say, let's go back to San Francisco. So we've got directions. So, if the user decides they're actually in San Francisco, the directions are updated. So let's close that off and zoom back in on San Francisco. And, as I zoom in, I get an outline on the Google Maps base tiles of the outline of the Moscone Center. So the next thing Brendan's going to talk about is overlaying a floor plan on that outline.
Thanks. So as Chris was saying, we're down to the level where you can kind of see the outline of the building, but not much information is there. That's kind of the, we got a typical Google Maps building here. It's pretty detailed for Moscone West, but there's no information about what's going on inside. And so that's what we want to do. We want to overlay some kind of floor plan on top of that. And we have a lot of different options. And it turns out the options are pretty much what's available for overlaying any information on top of Google Maps. It's just a matter of scale. Because JavaScript has one numeric type, it's a double precision floating point. It has enough precision to specify geolocations well below the pixel limit. So you can specify georeferenced data like arbitrarily as precise as you want. So we have two kind of classes of ways of overlaying data, and it's pretty much the classic computer imagery split between vector and raster data. So first we can talk about kind of vector floor plans. This is kind of a classic vector graphic where it's just very simple line drawing. And so typically, as most people already know, vector graphics are specified with kind of point data and then some kind of connecting data that says that lines connect these points or curves, or that the points form a closed loop to make a polygon. And the advantage of that is that you get to specify with just a little bit of data kind of detailed, arbitrarily scalable images. And that's great, but as soon as you start adding detail, you start kind of approaching that limit where if you start drawing in like trees and bathrooms and scale and stairs and that sort of thing, you start approaching the point when you might as well just kind of give kind of bitmap data instead. So there is that limit, but if you can keep your drawing simple, it's great. The other downside can be kind of parsing and computation time on the client side, if that's where it's displayed. The data comes in, but then depending on how it's displayed, it takes, whether it's Canvas or WebGL or if we go SVG or VML, that sort of thing, it can take processing time. So if we look at kind of the simplest way to do vector data in the Maps API, we start with kind of the geometry classes. This is the polygon object, and there's other things like polylines, that sort of thing. I don't really know what that's supposed to be. We could say it's like kind of the view of a visitor in the lobby of the Moscone Center. And it's really simple. You just provide a paths array, which is just an array of latitude and longitude coordinates. And then you kind of give styling information based on the stroke and the fill. And then you just add it to the map. And that's literally it. And you can make, you can start tracing out paths and outlines and that sort of thing. And what's great about this is that because it's added it's specified on the client side, you can actually kind of make dynamic data. So if like a floor plan changed based on the time of day or the time of year, that sort of thing, there's no reason why you couldn't just specify that latitude and longitude array dynamically and give a different set of coordinates for that polygon. So next up, if we want to get a little more complicated, you can actually use KML, and it's just that simple as you create a KML layer and give it a URL that points to your file available online. And KML is great, especially if you already have kind of a workflow that involves KML. If you use kind of geospatial products that output KML, or if you use stuff with Google Earth, you can use the exact same KML file with maps. What's interesting about this is that because KML can get quite complex, what happens is Google servers actually fetch that KML file, parse it, draw it to tiles, and then send that to the client. So that's great. That means like older computers and less able browsers have no problem with kind of more complex files. But you do lose a little bit in kind of being able to dynamically specify things. You can still do it on the server, but it's a little less flexible. So that's kind of the vector side of things. If we think about bitmap data, this KML kind of straddles that because it comes down as image tiles, and Fusion Tables kind of falls into the same place where it's specified. It can be specified with kind of shape files or other geographic stuff, but then it's sent down as tiles. So thinking about raster floor plans, if you want something like this, where you kind of have this nice drawn, quality where somebody considered each pixel, especially at this level is when you should start thinking about kind of raster floor plans, thinking about bitmap data. So the benefits of this is that the size is constant based on tile size. The number of pixels that you have, or the number of pixels you get, and you can actually specify much more complex shapes, but it's the data size is fixed based on the number of pixels you actually send. On the other hand, it's certainly not as dynamic. You'd have to do things on the server side. And it can be quite a bit bigger if you just are giving if it was just a simple outline, you'd have to specify every pixel. kind of instead. So the very simplest way to put an image on the map is the ground overlay, and it's pretty much dead simple. You tell maps that I want this image and I want it in this bounding box, and it just puts it on the screen. And it takes care of the fact, as you scroll around, it keeps the image in line, and then as you zoom in, it correctly places it. And so that's great. It's like 4 lines of code, like 20 seconds if you already have existing imagery. This works really well. And in addition, the bounding box is flexible enough at this level especially, where the Earth is essentially flat, or kind of local elevation stuff takes over, as opposed to kind of larger scale curvature, where you can essentially just think of it as an affine transform to place that correctly and keep it in line. The problem is, as we zoom in, you can start to see the problem with a single fixed image. Maps handles it well, but there's nothing you can do when there's no more pixel data. You start seeing the pixels as you zoom in. And so the classic fix for this is the eye of the image pyramid. It's been around forever, from MIP mapping to kind of those deep zoom kind of things. And the idea is that you start with a high resolution image, and at successful levels, you reduce the size and resample to get some really nice higher zoom, zoomed out imagery. The nice thing is, because you're doing this offline, you can do like a really high quality resampling and keep things really looking good. You're not dependent on whatever algorithm the browser uses to keep things real time. The other nice thing is that you can actually change the level of detail as you zoom in and out. So for instance, like on maps, when you start out at a city level, you only see major features of the city, but as you zoom in, you start to see building outlines. And there's nothing to prevent you from doing that. You could start with a very basic outline at the top level, but as somebody zooms in, you can start adding kind of room, walls, and other details from the sandbox area. So here's that in action. It's the image map type object. And when you create it, the most important part is this get tile URL. This is the main functional part of the class. And what it says is when you add this to the map, and maps loads a certain area of the world, it asks this method, so at this coordinate pair and at this zoom level, what image should I show? And so in that method, you would have some procedure for determining a URL. And so on the server side, typically you have a bunch of tiles. You have some kind of systematic naming method, which we'll get into in a little bit, to return the proper tile. And then you just insert it. And so what's great about this is we now see we've added kind of dashed red lines here so you can see the tiles. At this level, we have 5 tiles make up this map. But as we zoom in, it actually loads new tiles that have higher detail level. The tile size stays fixed, but we get more detail as we zoom in. And so now we can see that you can see really nice, high-quality things from the Android level. So the final thing with adding this raster data for your floor plans is, obviously the Moscone Center has 3 different floors, and you might want to explore those different levels before you get there. So to do that, it's actually pretty much exactly as straightforward as you would think. You want to add these maps, and as you select floor 2 versus floor 3, you want to hide the floors you can't see and show the floor that you want to see. So we take this data, we generate that image pyramid for each floor, and then on the map itself, we just add these buttons that on a click event kind of change this variable, this floor variable. And so show a different floor. And so the code to do this, let's see. There we go. So the code to do this is really simple. So we have this kind of floor variable just hanging out. And when a button is clicked, its click handler calls this change floor function with its floor number. It sets the floor value, and then it does this kind of tricky thing where it removes the image map type and then re-adds it. And the reason, or what that does is tells the Maps API just to check all the tile URLs again. It'll fetch all the tile URLs again. And if they've changed, then they'll load a new image. And if they haven't, they'll keep the same image. And it works well because it actually works with the browser cache. If it's seen a tile before, it won't fetch the tile again, but it will change the URL. So here you can see this is the get tile URL function again. And it's still just coordinate and zoom level, but you see we're redirecting it to another function that has an idea of how floors figure into things. And here it's really simple. We just have kind of a level floor number and then construct this URL out of that information. So that makes it really easy. Like Maps makes it really easy to put that on the map. But what I've kind of not mentioned is how you actually get that imagery onto the map. If you're a geospatial professional, you've had that problem figured out for decades now. But if you just want to get a floor plan on the map, it's not so easy. There's tools, but it's kind of hard to tell what's going on. So Chris is here to help you out.
So as Brendan said, if you're not an expert in this stuff, it's kind of hard, right? So I've had a bunch of people ask me. I started at Google about 8 months ago, and I've had people ask me how to do this stuff, and I kind of point them towards these tools. But before I'd agreed to do this talk, I'd not actually done it myself. Shameful to admit, but it's hard, right? So there's tools to help you to do this stuff. There's the great GDAL to tiles utility. You basically run it from the command line. It's a Python script. It's as simple as specifying an input file and an output directory, and it just goes and magically generates these tiles for you. Pretty simple, huh? And if that's not simple enough, there's a GUI to it called MapTiler, and so it's pretty nice. If you're interested in this stuff, go and check out MapTiler at maptiler.org. But you know what? We got this image from our vendors for Google I/O. They basically did all the fit out. But as you can see, this image doesn't have any concept of where it is on the world. In fact, it's not even rotated correctly. So, for this image to be placed on the map, we need to rotate it at a particular, number of degrees, resize it, and get the latitude and longitude for the bottom left and top right corners. So, or we could use the GDAL to tiles utility and georeference a few points, and it will go and automatically, transform this image to place on a map. So, all we need are these 3 coordinates. Pretty simple, huh? Right? So, but I don't know. I have no idea how to get, exact latitude and longitude for this image. It's a bit ridiculous, and would require a bit of trial and error, I think. So I've created this little tool called Overlay Tiler. So it basically makes georeferencing these images easy, and therefore helps you generate tiles using the GDAL utility. And once again, it's open source. I'll upload it straight after this talk to this URL on code.google.com. But what does it look like? So basically, let's zoom out. So basically, it generates 2 commands. First of all, GDAL translate, which basically specifies a bunch of control points. In this case, 3 control points for the top left, top right, and bottom right of the image, and says what latitude and longitudes at those pixel points. You give it an input file, and it outputs a GeoTIFF, basically a georeferenced image. So there's no loss in quality. It just goes and adds some more metadata to that image. And the second command is GDAL to tiles, which we talked about a little previously. You tell it what projection the source imagery is from. In this case, because we've given it ground control points on Google Maps, we're using WebMercator. And we say we want to generate tiles from zoom 16 to 19. So you could skip this second step and use the MapTiler GUI. It will go and actually figure out what appropriate zoom levels should be generated. And it outputs a nice directory of tiles, and in fact sample implementations using Google Maps and OpenStreetMap with the overlay on it. So this is a nice little GUI. The first thing I'm going to do is change the opacity of the layer so I can see the base map below it. And then I can just go and simply drag these 3 ground control points and move the overlay into position. So if I get that right, and this is really WYSIWYG, right? The tiles that are generated will look pretty close to what you're seeing right here. Oops, if I don't get that right. Anyway, so if I bump the opacity back up, that's basically what's going to be generated. So this uses Canvas 2D to transform the image inside the browser. So a similar transformation will be done by GDAL tiles. So now that that's all done, we could use the exact same command for all the different floors because the images are of the same dimension. So next up, I'm going to talk about annotating that indoor map. So having that base map is quite pretty. I mean, we've got great floor plans here, but let's show some of the features on the map. So basically here I've added markers for each floor and a bunch of sandbox sessions, and I can hover over. See, this is room 5, room 4, Chrome's over there, and I can also switch the markers depending on the floor shown. So what's the code for that like? So basically, it's data-driven. So for each floor, I define a bunch of different features. They have a latitude and longitude and the title that's shown on hover. And for each floor, there's a different set of objects, and they're switched on and off as the floor changes. So the code for that's on the right. I've modified the change level function to go and remove the previously shown markers, and then go and add a bunch of different markers at the appropriate floor. And they're just regular Google Maps markers. So there's nothing special about doing it indoors. So the next thing I wanted to do was make this a bit more exciting. I don't know about you, but the classic red pin doesn't really excite me. So I've added 2 different kinds of markers, blue ones for the sandbox sessions and red ones for the rooms. So, get the same interaction because they're just regular Google Maps markers. But it's an absolute pain to have your users hover over them to figure out what's there. So, wouldn't it be great to have labels just like there's labels on Google Maps streets and for various features on the world? So, I've decided create another library to do this. So what does it do? It's part of the Google Maps utility library, which can be found. Oops, sorry. I thought I had a link there. But it's part of the Google Maps utility library, which includes popular libraries like Marker Clusterer, provides dynamic rendering of map labels using Canvas 2D. So the advantage of this is you can dynamically change the text and position of these markers. In the process of creating the Google I/O map on the mobile app, we were often asked, move this marker a bit here, move this label here, switch these rooms, kind of crazy. So this made it really, really easy. There's lots of rendering options, font size, font face, color alignment, basically anything Canvas can do. And there's control over which zoom levels show which labels. So this is really useful for showing a different set of labels at different zoom levels. So as you zoom out, you probably want fewer labels so as not to clutter the map. And it's going to be open sourced, and it will be available at the Google Maps utility library page. So what does it look like? This is a really simple label. I just say new map label, give it a text and a position. Bump the font size a little bit, just for this demo. And the great thing about this is, as I zoom in, the marker doesn't get huge as though you'd just laid it on the base tiles and generated tiles. So you don't have to change the size of the text for each zoom level. It's just going to stay the same. So a quick demo showing how dynamic this is. I've just added a text box in the top right of the map. And whenever I click on the map, this text is going to be used to add a new label. So this is floor 3 of the Moscone Center. So we've got the keynote here. Android up over here, and room 11. So it makes it really easy to go and, if your data changes a lot or you want to have user-generated content, for example, if have your office staff go and be able to edit the map, this makes it really possible. So I've just gone and added labels for each of those markers. As before, as I switch through the floors, the markers change. And you'll notice, in a bunch of places I've got a label but no marker. And as I zoom in, you'll see I've added, in the previous zoom level there were no markers up in the sandbox because it would be too cluttered. And as I zoom in, they just appear. And so they're also right aligned. If they were center aligned, like the default, the markers would interfere and you wouldn't be able to read what's there. So these labels are really flexible, and it was a huge win when we were making the Google I/O map. So I'm going to talk a little bit now about searching over indoor features. So often your users don't know exactly the location of what they're looking for. So I'm going to demonstrate a simple way to enable this. So you can see here I've got a little search box in the top right. And basically what this is going to do is going to filter the markers on the map. So as I type in room, I'll see all the rooms. Also, I think the toilets are called washrooms, press room, etc. If I search for toilet, I just see the toilets. Chrome and geo. So I can see the geo sandbox as well as the room we're in right now. I added a little bit of metadata to that to say, this is geo. So this is all done in the client side. It's really quick. It's not exactly scalable. You might want to have that text box actually, go and ping the server to go and bring back new markers. And for example, if I want to see, toilets on every level, I can switch through them as well. So the code for that's pretty simple. I've gone and modified that add marker function we saw previously, and it's basically a giant hack. It just goes and does a regex over a bunch of different fields and just filters the markers out. So yeah, as I said, not scalable. There's definitely better ways to do this, but it's a really great feature to add to an indoor map. So Brendan's going to talk now a bit about navigating indoors using Street View.
Yeah. So Street View is great on maps. If you are searching for a place on a map, it's one thing to find kind of the intersection or kind of which part of the block something is on, but it's another to actually kind of go down into Street View and actually see kind of the facade of different buildings. And it's the same thing with kind of indoor mapping, or really any kind of place where there is no Street View coverage. It could be parks, it could be college campuses, what have you. So it's actually extremely easy to use Street View, and I've been kind of sad that there hasn't, or to make custom Street Views, and I've been kind of sad that there haven't been enough, but there is kind of a barrier to entry just in kind of, it looks more complicated than it is. So here's a couple of really cool ones that have been done. This is an agency in France called Digitas, and for their Christmas card, they made these, this kind of walkway into their office building. And they even did this kind of pseudo augmented reality thing where they've put these arrows and images into the Street View panorama. And so you can see only a few meters away. Exciting. Exciting. And there we go. Hooray. Let's see. And here's one the same agency did for Nissan, and they did this other pretty cool effect where they actually did kind of long exposure so they could write with lights on a stick. So So how do you make your own Street View? No, thank you. So Street View is done actually pretty much the same way that Maps itself is done. It uses the exact same projection that we use, the equirectangular projection, to map from a sphere or a spheroid onto kind of a flat surface that we can tile and represent easily with images. So if you can kind of imagine yourself at the center of a sphere and looking in each direction, at every point that you can address, there's a certain color, and that becomes your pixel element. Then we use kind of that latitude, longitude grid so we can actually give that point a name. And when we unfold it, it becomes this rectangular image just like a map, and we tile it just like a map. And then we can use that same kind of image pyramid technique that we talked about earlier to provide more level of detail and really fast loading on that first zoom level, but then progressive amounts of detail as the user zooms in. So yesterday, Chris and I went downstairs and we took some pictures of the lobby and then used just kind of a popular image editing program to stitch them together. There's a lot of these available now, and this is just the one that we chose. It kind of starts placing the images in place. Obviously, that's not what you want to use, but it kind of shows you how they start getting aligned to get the geometry correct. There we go. Then once the images are stitched together, it can do this kind of geometric correction, so it actually aligns them together and you get the proper projection to make things line up when we put it back onto the surface of a virtual sphere. So the code to do this is pretty easy. It's a little more complicated than image map type just because we need to provide not only a tile for a certain location and zoom level, but also a Street View node has a kind of a location itself in the world so that we can kind of locate them relative to each other and then link them together. So here we create a new Street View panorama, which is the view. We pass it these pano options, and the options just say that we want to start at the pano ID of lobby, the panorama provider that we're about to give with the ID lobby. And we say the pano provider, the object that's actually going to provide the Street View data, is this object right here. So it's actually a function that returns an object. But that role is usually filled in by Google Maps itself, and it requests that data from the Google Maps servers. But there's no reason that you can't put your own custom object there and kind of intercept those calls and then answer with your own data, which is what we're going to do here. So that get custom panorama is a function that returns an object that gives it has a location in the world, and at that location it has kind of a heading that points north. It has a pano ID, which is just a string that we're going to use to identify it, and then it has this get tile URL you can see, which is that same exact method that provides URLs for images for a certain view. And finally, so we just pass it once again to a really simple method that just appends some strings and produces a URL that gives the proper image URL for a certain zoom level and certain tile coordinates. It's a little bit different from latitude and longitude, but it's actually the same. It's just not the same numeric scale. So here we've taken that tile, or that image that we produced of the Moscone lobby, and we've made tiles of it, and then now we've put it in Street View. So this is just a normal Street View with imagery that we provided. There's a guy kind of checking his phone, and there's the entranceway and the escalators, et cetera. So now we have kind of a sense of where we are. But it also feels kind of lonely. Like I made a photo panorama in like 1997 in a Java applet. So like that's cool, but what's really cool is kind of the notion of Street View as this interconnected network that you can travel along and get a sense of space. So to do that, we kind of augment that pano provider. This is the same pano provider object. We still have that lobby ID. We still have a location. We have a nice description that shows up on the screen. But now we have this links array, which is an array of objects that describe the panoramas that that location can link to. So it hinges on that pano ID again, and so we're going to link to the Android floor. And it has a heading, which will just say those nice street markers that are overlaid on the image should point at 262 degrees from north. It's kind of a compass bearing. And then finally, this is just the same, get tile URL, nothing's that different. And so what this enables us to do is take two different panoramas. We took this one originally, and now we can link to the Android level and go right upstairs. And always go back down. I don't know, it's time traveling. Street view, it's cool. If you go in there, Jane's Addiction is playing. So I think we're going to attempt the demo gods here and actually show you the full kind of experience. So we start at the store locator level, and we're already in San Francisco. So here's the Moscone Center. And as we zoom in, we can start to see our imagery already overlaid on top. And here we go. It's loading. Here's outside the Moscone Center. We'll point this way. It's a little prettier. And then if we now have this custom link here, which is added in the exact same way as we showed before, where we just link to a public Google Maps panorama ID. So Street View imagery actually resides on your own server. It's provided by you. And obviously, we wouldn't link to kind of arbitrary Street View things because you can put anything you want on there. So but what you do is instead is when you get a panorama ID from Google Maps, from Street View. So when somebody says, I want to see Street View here, you actually just intercept that and add the same link that we showed before. You just add a link with an object that points to this location. And you can always head up to Android, go back to Moscone lobby, and exit again. And there we have it. You can even see, actually, I didn't mention this, but this is a really nice, it just does this automatically for you. Because we were searching for the Moscone Center, and it put a marker on the map, Street View automatically places that marker in the world correctly, so we can see that's what we were searching for right there. So that's all we have. So if you have any questions, please come up to the mic, and we'd be happy to answer them.
So quick question, for all this sort of metadata and stuff that we'd be creating for our own apps, is there going to be any way to potentially feed that back into search results or something else on the larger Google Maps? I'm thinking of like stores at a mall or products inside a store where you have levels, hierarchy of location.
Right. Do you mean like Google search proper?
Yeah, and anyway, I mean, it's sort of, a lot of times if you're searching for a store within a mall,
right,
it can be hard. So if the mall decided, let's make a detailed map,
right,
how could that sort of be bubbled back into, is that part of the plan or no?
So I don't really know too much about that. I work more from the developer perspective, kind of enabling you to put this on your own website. Sure. But yeah, I see that would potentially be quite good for Google and users. But yeah, I don't know much. Yeah, come and talk to me after.
Okay.
Yeah, it'd be great. Business place pages, is a good place to start.
I guess I have a similar question. To add like more media to the pins, like sound bites or video, is that an easy thing to do, or is that something in the works?
Yeah, it's just HTML, so you can put a click listener, you can do any sort of event listener kind of thing, and trigger audio. You can put things, and we didn't show this, but you can actually, people are getting cool results from doing things. Instead of just overlaying images, you can overlay a canvas like Chris showed when he georeferenced that building, WebGL, video. Somebody made a cool Mandelbrot Explorer where you could zoom in really far with Google Maps.
So if you're going to use the store locator library, and I'd love you to, there's actually an event that's triggered whenever the stores, whenever the selected store's changed. So you can hook into that, maybe ping back to your server for some more stuff. Show it anywhere on the page.
Play your store's theme song.
Yeah.
Thank you.
For the custom Street View, is there any way to integrate with the Pegman UI and get the blue lines and stuff?
Not really. I mean, that's a really hard problem.
Yeah.
I mean, you could show your own overlay on top, but if they intersect, it's there's not really.
Okay, so
I mean, that's a really good question.
There's no API level support for that right now?
There's no API level of support because the blue lines come down as image tiles, so they're already pre-rendered on the Google servers. So you'd kind of have to tell Google I have a location at this point. They would add it to the tile. So it's not feasible at this point, but you could certainly overlay your own blue line on that segment, and it would because they're mostly transparent pings, they would overlay correctly together.
So if we made our own map tiles, then is there a way to use the same Pegman that you use? Because right now, when you drag in your Pegman, it comes up with the street views of the road. But can we intercept that somehow so that it's seamless for the user?
Yeah, actually, no. You can't get the drag start for the Pegman or something like that.
Okay.
But yeah, that's a great feature request.
Okay. Thanks.
Actually, about his previous question, I thought you could do stuff like that with fusion tables. If I loaded a KML shape in to a fusion table, I could just fuse that in and get it back in the rendered.
Yeah. It's just a matter of how interoperable they are. But if you want to replace it completely with your own blue lines, that's sure.
Okay. So my question was a little bit different. So let's say if we go back to the Moscone view where you had all the kiosks set up, and let's say it's the conference, these rooms here, and I wanted to click on one of those and get what the next session was. In order for me,
sure.
so in order for me to do that, I need to be able to intercept that event and convert it into the coordinate system that my original metadata is in. So is that part of the API?
Sorry, so you're talking about inside Street View, clicking it?
Whether it's inside a Street View would be cool too.
Okay.
But whatever metadata I've overlaid on top of whatever visualization I happen to be using, I need to be able to convert my gestures back into that entity, whether it's in the coordinate system that I'm dealing with, or you can link it directly to one of the entities. I need something to latch onto so I know what it is that the user is interacting with so I can provide the appropriate response.
So have you used the Google Maps, the Google I/O map on the Android app?
I have not yet.
Oh, so we've actually got some really nice integration there. Whenever you click on a marker pin on your phone, it actually tells Android, the native app, that something has been clicked, and some a little thing slides out and shows you the sessions that are coming up.
I don't want to use the markers because red or blue or whatever, I hate them, right?
Right.
So let's think about a conference room outline, right? Where I want to book I just want to book this room that I've just clicked on.
Sure. Okay. I mean, you could use a polygon, and in the same way, you can listen to a click event.
Okay.
Or if polygons are even too much to do, you could listen to a click event on the map and send back those coordinates to your own server, which could then maybe send back what was clicked there.
So
or you could use
you
fusion
do the
tables.
Translation though?
Sorry?
Your APIs do the translation into the base coordinate system?
Yeah, you can project back into latitude and longitude coordinates. Yeah.
Okay.
Yeah.
Okay. All right. Thanks. Even with rotation and stuff like that in the map, you guys are doing
Yes.
the translation.
Well, I mean, so the Maps API doesn't support rotation now. It does on mobile, but yes, that would be added along it when rotation is added. Then yes, definitely.
All right. Thanks, guys.
Are these cool features well supported in mobile browsers, typically like Android and iOS?
So what specifically?
I mean, most of the features are they supported? Or?
Sure. I mean, so generally the Google Maps API v3 was designed with mobile in mind. Things are really quick to render in on mobile. A lot of work was done to reduce latency. And so all of these features that are shown here are supported on mobile as well. In fact, this map that you're seeing here is essentially the same as the map you see on the Android I/O app.
So any thoughts on how to tell the user where they are on this map? Because this room is pretty nondescript, and I don't know that I'm in room 7.
Sure. You know, a lot of work has been done about indoor geolocation. I don't really know too much about that. You know, it's quite coarse from what I understand. You know,
it's a really hard problem because not only are you kind of in a nondescript room, you're also blocking all the signals from things that want to get to you. So there are ways of doing things where you can actually put kind of essentially beacons inside a building, but they're all pretty much custom solutions. There are also really interesting ones where you can do kind of machine vision, like kind of figure out where you are based on like if you actually take out a picture, but nothing automatic. It's a hard problem, and you know, hopefully somebody will figure out something cool.
Thanks.
Hi. Is it possible to play some video in panorama mode somewhere in the tile in the street view?
So the question is, can I put video, you know, on the map or street view?
Yeah.
Sure. I mean, we have the concept of an overlay view in Google Maps, which essentially lets you put any DOM element on the map, and it can be attached to a particular latitude and longitude, so it would be dragged around. That's certainly possible. In Street View, not so much, I think, yeah.
It won't be correctly placed. But there's no reason, I mean, because it's HTML, like there's no reason why you couldn't insert into there. Yeah.
Yeah.
Okay, thanks.
Great. If there's no more questions, thank you very much.